All right, good morning, guys. We are going to talk about the electromagnetic spectrum. Now, the electromagnetic spectrum is the entire range of frequencies and wavelengths in the electromagnetic spectrum. Electromagnetic waves are forms of light energy, so this is a little bit different from what we talked about with mechanical energy, like the string lab. It is used for a host of different purposes. Most good, some can be detrimental. 7 categories, kind of going from the largest at radio waves, microwaves, infrared, the visible light spectrum, UV, X-rays, and gamma rays. Now, do not try to rewrite this entire thing. Really, there's a few things that I'm going to show and talk about when it comes to this slide. But, to get those takeaways, don't try to rewrite everything on here. All right, so first I want to talk about wavelength. Wavelength is large, or the longest down on this side where you have the radio waves. So, since we have very large wavelengths, we actually have very low energy, okay? So the energy here is fairly low because our wavelength and our frequency, our wavelength is very large, so our frequency and our energy is very low, okay? Now, on the other end, we have very, very short wavelengths. 10 to the negative 12th is, I think, a trillion. We're close to it. Could be wrong. Been wrong before. Probably be wrong again. But our frequency and our energy is very high. So as wavelength goes up, energy and frequency goes down. So on the flip side, as wavelengths go down, like how far apart they are, remember that's a wavelength, the energy goes up. So we've talked a lot about this and just understanding correlations and relationship. This is an inverse relationship. So wavelength, if we compare it to frequency and energy, they are inverses of each other. So as one goes up, the other one goes down. So let's talk a little bit about each of these categories. Radio waves, these are the lowest frequency and the longest wavelengths. They'll be able to pick up by antennas in your car, truck, house, whatever they are, and used for broadcast, satellites, radar, things of that nature. Microwaves, the form of radio waves, they're shorter and higher frequency compared to radio waves, like radio as in listening to the radio. They're able to penetrate food and cause it to get hot. So the way a microwave works is, microwave specifically, is that it vibrates the water content that is found in your food. They vibrate at the same wavelength, so the water molecules start to move up, and in moving faster, they end up warming up the food from the kind of the inside out. Now, why in the world the bowl gets, feels like 1,000 degrees and your food can still be cold, I don't know on that one. But they're used for Wi-Fi, traffic communications, all that kind of stuff. Infrared, these are shorter. Like I said, we're kind of going as far as the wavelength. We're getting shorter and shorter and higher frequency as we go through this these different types of electromagnetic radiation. Can be felt as heat in incandescent bulbs. You hear about people using infrared goggles and things like that in video games and in real life too, of course. But so these are right at the beginning before we get to the visible light spectrum. So the visible light spectrum, this is what we see with our eyes. Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. Red being the longest and violet being the shortest. Okay. Ultraviolet, these are on the end of the violet scale, so they're just right outside of what we can see. They can be beneficial and harmful. This is one of the reasons ultraviolet light is one of the reasons you get sunburned. Also, it's, make sure that your like sunglasses have UV protection on there because it can hurt your eyes. It can be used to sterilize surgical equipment, but also treating jaundice. So like I said, it has some great purposes, but also it has some negative purposes. So like I said, it comes from the sun, tanning beds, all that kind of stuff can cause cancer, as we know. X-rays. All right. These are obviously good. The wavelengths are short and pass through many opaque objects, or more or less solid objects, able to penetrate the human body, but not able to necessarily go through all the bones. So that's why the bones show up and your skin does not. The reason that the lab technician goes behind the big, huge wall is because if they get too much exposure, it can cause cell damage and eventually cancer. So you getting X-ray done every so often, it's not a big deal. But somebody whose job is to literally take X-rays all day, they have to be careful. Some nurses actually wear a certain type of badge, and it measures the amount of radiation they're getting. And if it gets to a certain point, they actually have to stop and take time off, whether they like it or not. Gamma radiation. This is the highest amount of energy, therefore the shortest wavelength. It contains a great amount of energy given off by stars, radioactive substances. It can help diagnose and kill cancer, but it can also cause cancer as well. This will not turn you into the Incredible Hulk. Okay. That's what happened to Bruce Banner, but in actuality, that is a total lie. If you got hit with a enormous amount of gamma radiation, you would probably just end up with, stage 4 cancer. Example is in the Manhattan Project, when the scientists were developing the first nuclear bombs, most, I think if not all of them, died of cancer due to the gamma radiation given off by the uranium and the plutonium that they were using. All right, so some quick questions. What is the electromagnetic spectrum, and explain it in your own words. Just try these, answer them. We can talk about them on Wednesday. Describe the relationship between frequency and wavelength of the electromagnetic spectrum. Identify one way understanding that electromagnetic spectrum is beneficial. So what are some ways that it is beneficial? So quick one, I wouldn't ask you exactly like what, between like this part of the wavelength and this part of the wavelength, but I could very well ask you on a quiz, like at this far into the spectrum, what would you expect to find? And then on this far spectrum down into the spectrum, what would you find? That's a perfectly valid question because those are fairly far apart and there shouldn't be any mixing those up. So just to go through these real quick. We have short wavelengths and high energy, so this would be like gamma radiation. Down here we have large wavelengths, low energy, so this would be something like a radio wave. All right, that's it. Quick little look at the electromagnetic spectrum. We will talk about this on Wednesday.